Hi everyone, in this practical work 4, generic skill presentation 2, semiconductor devices by our lecturer, which is Sir Muhammad Faris bin Hamdani, presented by Shah, Era and Terry. Our team member is consists of Muhammad Ishwan Shah bin Sabini 20DE 24F1066, which is me. Era Natasha binti Muhammad Yahya 20DE 24F1059. And the last one will be Terry Laveno Ana Ariang 20DE 24F1069.
Okay, good morning. Today I want to present about BJT. The objective of BJT is to learn, apply the principle of operation of BJT to basic resistor common emitter CE configuration. So BJT have a principle in configuration. So first of all, the emitter is the common terminal for the port and output. The second one is the input is applied between base and emitter. So the third one is the output is be taken collector and emitter. The last one is the transistor operation in active region of amplification. For the first, the base emitter junction is forward bias and the collector to bias junction is reverse bias. So the learning outcome is able to recognize a type and terminal of BJT via datasheet. The second one is the able to conduct the circuit of CE configuration. The third one is able to measure voltage and current in the circuit using a multimeter. For the last one is to able to determine the base of beta of the transistor. So BJT is the bipolar junction transistor. A bipolar junction transistor is a three-terminal semiconductor device that amplify or switches electric signal. It consists to the PN junction and come in two type NPN and PNP junction. So the difference of two type of transistor is from for PNP and NPN. So the structure of PNP is it have two P types and one N types. Also for the NPN, it have two N types and two N types and one P types. So the majority carries is for NPN is electron and for PNP is the holes. So the emitter error is for the PNP is inward and for NPN is inward and for PNP is outward. So the current flow PNP is the emitter to collector and the NPN is collector to emitter. So the last one is switching time. So PNP have the slower time and NPN is the fastest time. So I pass this slide to my friend. Thank you.
Thank you for your explanation, Era. Allow me to continue this slide. What you can see here is a transistor. A transistor has three legs. The leg on the left one is emitter. The leg on the middle one is base, and the leg on the right one is collector. You can see here in the schematic diagram, collector is connected to base, and base gives some sort like arrow into emitter. This is the formula we will use for this practical work 4. IE equal to IB plus IC. IC almost equal to IE. Beta equal to IC over IB. Reason for this to use this formula is to able to help us predict the outcome of the value of the circuit. More accurate measurement and testing allow to know the value of transistor amplify the base current. This is the component for this practical work 4. We have DC power supply 10 volt and 20 volt, resistor 680 ohm, digital multimeter, transistor BC108, BC109, resistor 820k ohm. For work instruction, connect the circuit as shown in figure 4.1. You can see here, it is common emitter configuration circuit. Switch on the power supply and set it to 10 volt. Using a multimeter, measure the value of IB, IC, IE, VRB, VBE, VRC, and VCE. Fill in the value obtained in table 4.1. Switch off the power supply, set the power supply to 20 volt, repeat step 3 and record the value obtained to table 4.1. VCC equal to 10 volt, connected to series with RC, which has the value of 680 ohm. RC is connected to IC, and you can have RB here with the value of 820k ohm parallel to RC, and RB is connected to IB, and you can see here IE is connected to ground. This is how to measure and find IB, IC, and IE. For IB, you put a red probe under RB and the black probe in the leg of in the current arrow in the transistor. This is how to measure IC. You put a red probe under RC and the black one on IC. This is how to measure IE. You put red probe on IE and the black one near ground.
Okay, my name is Terry Leveno Anariang from the E2C. Okay, today we went to present about how to measure find VRB, VBE, VCE, VRC. Okay, next, this is a result from IB, IC, IE, VRB, VBE, VRC, VCE. Okay, how we to calculate the value of BDC. B equal to IC per IB. Okay, put the value in the put the number in the formula. For example, 1.11 milliampere per 1 microampere. Okay, the answer is 71. Okay, in the conclusion, by applying the principle bipolar junction operation in all common emitter configuration, we gain a fundamental understanding of transistor behavior, amplification, and switching application. Okay, that's all.